Yeah, sorry. Yeah, outcome logic, which is a monad parameterized logic that extend Hoare logic, and hyper Hoare logic, which further extend the outcome logic, but instantiated with the powers monad. And in particular, the two logics are pretty similar. They both lift the assertion language, going from predicates to hyper predicates. And by doing this, they show that they can subsume several existing program logics. In particular, they can also prove and disprove any triple within the same logic. And in this talk, I would like to argue that the predicate transformers deserve more attention because, as we are going to see, they subsume existing program logics, and also they have some advantages in the sense that they can find the best possible precondition or the best possible postcondition. So in particular, I would like to recall our previous work, which shows how we can define several logics by using predicate transformers. And for partial correctness, I have already said that we can just under-approximate the weakest liberal precondition. For angelic total correctness, also known as Lisbon logic or sufficient incorrectness logic, which means that every state in the precondition P has a path that goes into the postcondition Q after executing the program. And here we can just under-approximate the angelic weakest precondition calculus. Then we also defined partial incorrectness in our previous work, which is equivalent to finding necessary preconditions from Couzeau. And this means that every state in the postcondition Q is reachable only from states in the precondition P, if it is reachable at all. And this is equivalent to under-approximating the strongest liberal postcondition. And also incorrectness logic or reverse Hoare logic, which means that every state in the postcondition Q is reachable from the precondition P. This is equivalent to under-approximate the strongest postcondition. Okay, now I have finished with the introductory part, and I will show how we can lift the weakest precondition to our weakest hyper precondition calculus, which is a weakest pre-calculus for hyper Hoare logic. So the idea in the weakest precondition calculus is that they reason about predicates, and the predicates are just function from program states to either true or false, so to Boolean values. Instead, we will reason about hyper predicates, and hyper predicates map program states, map predicates to true or false, or maps states to either true or false. So for the classical weakest pre, the idea is that we plug in a postcondition, and in this case, we can take as example x less than 5, and we have a program. Here we increase x by 1, and we want to find a precondition, so a condition over initial states, such that all the states in this precondition after executing the program C will terminate with x less than 5. And clearly here the precondition is just x less than 4. So we can think of this weakest precondition as a forecaster, because if we plug in initial state sigma, what it does is to anticipate or predict the truth of the postcondition, but evaluated in the final state. So it anticipates the operational semantics of the program for a given initial state. For the weakest hyperpre, as I said, we reason about hyperpredicates. So instead of a postcondition, we have a hyper postcondition. And a hyper postcondition can be a condition over sets of states. For instance, here we have the sets of all sets of states such that there exists at least one state with x equal to 0. And we can think of this as a bug, for instance, or in general, this is also referred to main constant analysis in control flow graph analysis. And here we want to find again a hyper precondition, so a predicate over set of states. And clearly, I'm not showing all the computation, but this is basically given by the sets of all sets of states where there exists a state with x equal to -1. Because if we run the program, we will terminate with x equal to 0. And again, we can think of the weakest hyperpre as a forecaster, because here we plug in but a set of states instead of a single state. And what it does is to anticipate the truth of the hyperpass condition, but evaluated in the sets of reachable states after executing the program. And the set of reachable states is just given by the strongest post condition. So here we are just anticipating the strongest post condition. We can show that our weakest hyperpre subsume or is equivalent to hyperhorologic triples. And since hyperhorologic triple subsume several existing program logics, all the one that I have mentioned before, then we obtain for free that we also subsume these triples in our setting. And more interestingly, we can also show how to falsify this triple by means of predicate transform semantics. And this is also related to the existence triples that Lena has mentioned in the previous talk. So to falsify a partial correctness triple, we just need to find a state in the precondition P that has a path to the post condition not Q. That is, has a path that goes outside of Q. So we can just intersect with the angelic weakest precondition. To falsify an angelic total correctness triple, or also a Lisbon logic triple, sorry, yeah. Sorry? To falsify a Lisbon logic triple, we just need to find a state in the precondition P that has no path to the post condition Q. So we just intersect with the demonic weakest liberal precondition. Then for partial incorrectness, which I recall it means that every state in the post condition Q is reachable only from the precondition P. To falsify this, we just need to find a state from outside of P, such that this state here goes into Q. So we can just intersect with the strongest post condition. And to falsify an incorrectness logic triple, which means that every state in Q is reachable from P, we just need to use the strongest liberal post, which finds all the states that are reachable only from outside of P, and we intersect with Q. So we ensure that there is a state in Q that is not reachable from P. And all of these triples can be expressed with our weakest hyperpre transformer, so with a single transformer. Now, let me show how to lift the reasoning from predicates to quantitative reasoning. So for the quantitative weakest pre that already exists, the idea is that to use functions from program states to real values instead of Boolean values. And we will lift this to hyperquantities, which are functions from quantities to real values. So let me show how the quantitative weakest pre works. So we have a post quantity as opposed to a post condition over final states. And for instance, we might be interested in the value of the variable x. And here we have a probabilistic program that with probability a half, it increases x by 1, and with the same probability, it increases x by 2. And we want to find a pre-quantity that is able to tell us what will be the expected value of x, but after executing the program. So in this case, it is just x plus 1.5, because on average, we can think that we are increasing x by 1.5. So again, we can think of WP as a predictor. Here we plug in a single state, and we obtain the expected value of x, but in the final distribution. For the quantitative weakest hyperpre, we use hyperquantities. So here we have, for example, a hyperpass quantity over final distribution, probability distributions. And as an example, we might be interested in the expected value of x for any given distribution. And we want to find the hyperpre quantity, which in this case, it's very similar. It is just the expected value of x increased by 1.5. So we can think of the weakest hyperpre as a predictor, but here we plug in a probability distribution instead of a single state, and it anticipates the value of x, the expected value of x, but in the final distribution. And even though this seems very similar, there is a main difference, because here we are making it very explicit that we are computing the expected value instead of, in some sense, hard coding that in the calculus. And in particular, we can also choose different hyperquantities. For example, we can think about the variance for any given probability distribution or any meaningful measure over probability distribution. Or we can think about the maximum hyperquantity or the minimum hyperquantity, which for a given probability distribution, what it does is to compute f in the support of the probability distribution and take the maximum or the minimum. As an example, if we have a program that after the termination of the program, it stores in a variable n the number of requests that we perform to a database, for example, then with hyper-Hoare logic, one might be able to prove this triple, which tells that for every initial set of state, the mean number of requests is bounded by 100. But the problem of this is that it might be false, because maybe for some initial state it is not true. So one might try to find the right precondition, which might be hard. Or also the bound might be loose. So in general, it would be a lot better if we can simply measure how many requests we perform. So with the weakest hyperpray, we can do that, because this expression here tells for any given initial distribution what's the expected number of requests, without the need to try to guess a bound. And now let me show also how we subsume some existing transformers. So let me show how the angelic weakest prey works. So here we plug in a post quantity and an initial state. And what WP does is to predict the final states and then compute f over all these final states and then take the maximum. And we can clearly mimic this using our weakest hyperpray by using the maximum hyperquantity. So we make it very explicit that we are finding the maximum. And instead of plugging a single state, we plug a probability distribution. In this case, the direct delta probability distribution, which and basically WHP will compute the final distribution and take the maximum over the support of this distribution. And we can do it very similar for weakest liberal prey, which just takes the minimum instead of the maximum. And more formally, one can show that our previous transformers are just specific instantiation of our calculus. And also the existing weakest pre-expectation transformers can be seen as instantiation of our calculus. And yeah, as for the, let me recap what we have done. So we have proposed the weakest pre-calculus for hyper-Hoare logic, and we enable quantitative reasoning. And also we show how to reason about correctness and incorrectness using a single predicate transformer. And for future work, we plan to further investigate a forward variant of our transformer and to develop transformers for outcome logic. Thank you for the attention. Any question?
So we have plenty of time for questions. Patrick.
I see that you are enthusiastic about predicate transformer. I am too. The problem with WP and WLP is that they exclude runtime errors, and which is a cause of incorrectness. So in a sense, you exclude at the beginning a number of possibilities that are interesting.
Yeah, I think we can try to model these kind of errors. Maybe adding some extra states to check if we reach one of these errors. So in our work, we don't. We have a very simple semantics, but I think there can be extensions to model these kind of things.
Yeah, they can be extended, of course, but you should extend it, I would say.
Any more questions?
So the normal, like, non-hyper properties correspond to, like, if I write an assert in the programming language, then, you run the program, it trips the assert. And so it can be connected to testing very easily. Do we want to write hyper properties in the programs, or is it, I understand the probabilistic case, but is it for meta theory, or do we want to actually write these things in a program?
So I think for non-probabilistic cases, I think it's mostly meta theory. But so my take is that if we study properties over hyperquantities, so hyperproperties, then we might be able to derive simple logics for other use cases. And one can show that, for instance, if we have linearity, we obtain the standard weakest pre-expectation or things like that. So yeah, it's meta theory, but I hope to get some real logic, some
Okay.
yeah.
Okay, you can set up. Any other questions for Linpeng? Going once?
Can I ask one more?
Please.
You have one weakest pre here. So Linpeng, you have one weakest pre here, and you're characterizing like loads of other predicate transformers.
Yeah.
I mean, is there only going backwards one meaningful predicate transformer for hyperproperties, or are there other ones that you just haven't studied?
I think for hyperlogic, this is the only one, and I think this is also the liberal. This is also the liberal transformer because we have some properties. And, yeah.
Okay.
So this is the only one.
This was just switched off.
Okay.
This now works.
Okay. Set up, Heike.
Yes.
So let's thank Linpeng again.